We've covered a lot of disturbing, distressing subjects here on the infographic. According to Cosmopolitan's 18 Best Feelings in the World, some of the most pleasant feelings humanity can experience include taking off a bra at the end of a long day, climbing into a freshly made bed with clean, soft sheets, stretching, releasing the tension from your muscles, snuggling a furry, cute animal, triggering a release of dopamine with their fluffy little face, finishing a difficult workout, sitting on the beach and feeling the sand between your toes, sleeping in as long as you want to on a day off, and wrapping up in warm blankets when it's cold outside. Dr. Yvonne K. Fulbright of the Huffington Post put together a list of receiving some unexpected financial help, feeling your partner from head to toe, skin on skin, learning that the person you're in love with loves you too, and accomplishing something huge. Back over at Psychology Today, Dr. Marty Nemko assembled a list of pleasures accumulated
time, and with practice, everything just starts to make more sense. And with time and with practice, you just get better at this particular field. And indeed, really, the key to success in programming in general is just to allow yourself time. And so at least thankfully, I quickly got into the habit of starting early in the week, for instance, when writing actual code. Why? Because you're gonna like run up against a wall. You're not gonna see some bug. Something's not gonna jump out at you, and that's fine. That's when you sort of call it a day, take a break, move on to something else, and then just come back to it. And that's what keeps programming fun for me, even all of these years later, whether it's teaching or actually applying it. But there's down the road a history of an MIT hack, and it looked a little something like this in yesteryear. And there was a little sign the MIT students, when they made this hack, on the wall that says, "Getting an education from MIT is like drinking from a fire hose," which indeed they have connected to what should have been otherwise just a water fountain. And that's going to be what it feels like sometimes, not just in computer science per se, but just an unfamiliar field. If you're not from STEM, if you're not from CS, that's fine. But so much of it ultimately is going to be absorbed by you and going to be within your grasp by term's end. So just keep in mind that's very much the intent, but you'll be amazed what you're able to create, to accomplish just 3 or so months hence. Indeed, 2/3 of you, contrary to what you might think or assume, have never taken a CS class before. So it's absolutely not the case that the person to the left and to the right surely must know more than you. Indeed, it's quite the opposite. And as you'll see in the coming weeks, as you write your own code and solve your own problems, what ultimately matters in this course is not so much where you end up relative to your classmates, but where you end up relative to yourself when you began. And it really is all about that delta, whether you've programmed or not, just getting something out of a class like this. And if it does take time, and if you do feel those frustrations, but you simultaneously eventually feel that sense of accomplishment, that just means it's all working. And indeed, hopefully, all the more worthwhile and gratifying ultimately as a result. So what are we going to do in the coming week? So here we are in week 0. We'll soon see why computers and computer scientists start counting, if you will, from 0. But week 0 is one in which we explore computational thinking, sort of thinking like a computer and starting to clean up your thought processes, getting you to think, to solve problems more methodically, and then ultimately translating that into code. And some of you might recognize this environment here, aka Scratch, coincidentally also from MIT. You might have used it in grade school. We'll use it today and a little bit this weekend in the course's first homework assignment or problem set, but not so much to kind of play around in a way that you might have if you did use it in yesteryear, but to explore ideas of computer science and programming that we're going to use and reuse every week hereafter as well. Thereafter, we're going to transition just next week to week 1, so to speak, whereby we'll introduce you to a more traditional language, a lower level language, an older language called C. And in C, you're going to use your keyboard, not so much your mouse and pointing and clicking, but you're going to write code that soon is going to look a little something like this. And if you've programmed before, you can probably glean what this is going to do. If you've never programmed before, which is the case for most of you, this too will soon make sense. sense. But this is the most canonical program that most any programmer ever writes, called Hello World. And indeed, that and all of the surrounding syntax above and below just that sentence, Hello World, will soon make all the more sense. You'll learn how to use industry standard tools, so to speak. Pictured here is something called Visual Studio Code or VS Code. You'll use a cloud-based version of it initially, so you don't have to suffer with any technical difficulties or headaches like that. It'll just work right off the bat. But we'll use that tool and others ultimately to then explore ideas in computer science, principles that you can apply. And we'll take a look underneath the hood, so to speak, of your computer at your memory, or RAM, random access memory, where all of the data is ultimately going to be stored. We'll also take a look thereafter at bugs. A bug is a mistake in a program. Here is an actual bug in an actual computer in yesteryear. But we'll teach you how to debug programs, find your own mistakes, find others' mistakes, and improve that code as well. We'll transition then to algorithms, step-by-step instructions for solving some problems, which we'll touch on today too. And if you picture here, this is actually a pretty representative problem.